This is the noob, and this video is going to be over uh, not just how to build RCBasic, but also how like how to add functions and a few other things with how the code actually works. So the first thing we're gonna do, even though I do already have this cloned on my system, obviously, I'm gonna start with just cloning it and doing all this from scratch. So, and by the way, I'm on Ubuntu right now. So, I mean, like if you're on Windows, as long as you have Git installed, just go through it however you open up a terminal in Windows and follow along. So I'm just gonna type in Git clone and uh, I'm gonna copy through SSH. I think HTTPS, yeah, it should just work just fine if you don't have your SSH key set up, but I do, so uh, and all right, so we have it cloned. We don't. We're just going to build the main branch, and there are there's stuff set up in here to allow you to just build the entire thing from scratch, like these batch files and stuff. Once you have a bunch of environment variables set up. But I'm not going to do that here. Instead, we're going to build code blocks projects from scratch. So let me, and I do have code blocks open already with my current projects, but I'm going to close these and we're going to set up a new project for the compiler. So project, and I'm in code blocks, by the way, so I would recommend getting code blocks and installing it if you want to follow along. I'm not going to go through how to install that because I mean, it's how you install any other piece of software. So I'm going to go to console application and next C++, next, and I'm going to go to where I have this at, and I'm going to name my project RCBasic underscore build, so it'll add that project to that RCBasic underscore build folder. So I want it in the RCBasic 3 directory, and I'm going to call it RCBasic underscore build. And this will add the project to the RCBasic build folder that already exists, which is what we want. And then we click next, and next again. And this part's important. I don't want it to override the current main.cpp. So I'm going to hit no. And now when we open up main.cpp, we should just have, yeah, the file is there. So I'm going to go ahead real quick and add all the other files from the all the other .h files from the RCBasic build folder. So just take all the .h files and add them to your project. Yeah, that's all of them. And hit open, and we want to add it to debug and release, and hit OK. Just in case I was going too fast and you missed that, you right click on the project and you just click add files, and it'll bring up all the stuff I just did. So now that we have that added, the compiler actually really technically doesn't have any actual dependencies, but it does use SDL, and so it will probably require us to link against just SDL. So I'm gonna go to build options and go to the where the project is, click on that, and then I'm gonna go over to linker settings, and I'm going to have like add -l SDL to main and actually not even that, just -SDL2. We don't need SDL2 main. So dash SDL2 and hit OK. And now I should just be able to build. I hope. Alright, and it built. Then this is the compiler we just built. Um, Now we're going to set up another new project for the runtime, the executable that actually runs your code. So we'll go to new project. We're going to go to console application again and hit that. And we're still going to be in the RCBasic 3 folder, but now we want to name our project RCBasic underscore runtime so that it makes the runtime inside of that, the project inside of that folder. So call this RCBasic underscore runtime, and it needs to match the name of that folder so that it creates the project in that folder. It's kind of a ghetto way of doing it, but it works. So, and finish. And yet again, we want to keep our current main.cpp file from the folder, so we're going to hit no. And now we have this added, and now we need to add all the other files in that folder. So go to add files, and we are going to add all the .h files. And we also want to add the theoraplay.c. You don't really need to add these other two theoraplay files since these are like part of a library that I'm using, but we're not going to be troubleshooting the library itself. But you can if you want. I'm going to leave them out for now, but make sure you add theoraplay.c. That file is required. And hit open and add to both. And now we also need to set this up so it will build with all of the required dependencies. So I'm going to go up to build, well, actually not build, up to project, build options again. I'm going to go up to the top and go over to linker settings. And this is going to be long. So first we need to link against dash. So dash L for link against SDL2 main and dash L SDL2 and dash L. And if you can't tell, I'm putting a space between each of these. It doesn't look too much like it probably, but there is a space in there. So yeah, dash L and RCBasic uses all of the SDL2 libraries. So make sure you have them installed on your system, and then do dash L SDL2 underscore image dash L SDL2 underscore GFX dash L SDL2 underscore mixer dash L SDL2 underscore net and dash I think that's all the SDL libraries. And now we need to link against the Theora library, so we need dash L og dash L vorbis file and then dash L Theora and then dash L Theora DEC, which is the Theora decoder, and then we need dash P thread. I think it's just singular. It's not plural. We'll find out. So yeah, that should be everything. Try to stretch this out so you can see the whole thing. I don't even think it's possible to stretch it out that far, but yeah, all of this and hit OK. And now, if we did everything right, it should just build. I always get scared when this runs because, yep, uh, that. See this, if you get an error saying undefined reference to something, it means one of those dash L's is either wrong or miss. Actually, it means there's a dash L missing. So, and this dash L is related to Vorbis. So I think, uh, I think there is like just a dash L Vorbis along with dash L Vorbis file that you have to have. Oh, I missed one more SDL library. So we also need SD. It uses SDL TTF2. I'll throw it after GFX. So dash L SDL2 underscore TTF and build that now. All right, yeah. So if you get this, that means it built successfully. Um, Also, after it built successfully, I would go ahead hit save project and then double click on RCBasic build and save that project too. Because it Code Blocks does this weird thing where it doesn't automatically save your projects just because you built them. So now we have both of them building successfully. I'm gonna go into how to add functions to RCBasic. So it starts with the compiler. So let's go to main.cpp and oh, we're already there. And inside of here, I'm gonna open up another file, another folder where actually the folder I think is already open. Yeah. So inside of this RCBasic underscore build folder, there's this file called embedded functions.bas. Those are all the built-in functions. I'm gonna open this in Genie. There you go. So these are all of the built-in function. You see it's just like a function definition on each line. And these are like these are what's going to be read into the compiler when I uncomment a certain line. First of all, we're just going to just add a simple test function. So we'll call this function test and we'll give it a string argument. So arg, and then we save this. So now to get this into the compiler, we're going to go down to the main function and we're going to uncomment this line. And then we are going to build and run RCBasic underscore build. So you can either hit F9 or go under the build menu, hit build and run. Alright, and if you see all of this and you see RCBasic dev file was created, that means it ran successfully. So now it didn't add anything yet. What we want to do is next open up, where is it? Built-in, rc underscore built-in.h. And this is like a long string of like stuff for adding all of these built-in functions. Um, we're not going to manually put anything there. Instead, Inside of our folder, uh, inside of our RCBasic folder, underscore build folder, now we have these three files: RCBasic underscore dev, and then underscore dev2 underscore dev3. Let's just go ahead and open up all three of them because we're going to use all three of them in certain parts. So I'm going to open them all up in Genie. First, we want what's in RCBasic underscore dev, and this is basically all that stuff I just deleted. I'm going to copy all of that, and then I'm going to paste it inside of this init embedded function inside of the RCBasic underscore build.h file. So just paste it. And you see the last thing it's adding is this test function that we just created. So let's go ahead and save that. And now we can comment this back out because we don't need this anymore. And we hit build again. And there's a lot of code to build, obviously. Yeah, so now we have it built, and now it's built with this test function we made added. But that's only adding it to the compiler so the compiler knows that that function exists. For that function to do something when you call it, we have to add it to the runtime as well, which means changing two things. First of all, in main.cpp for the runtime, we're going to scroll down to this gigantic switch statement, which is inside of this function. It's called this function called func underscore 130. This is where all of the built-in functions are at. So when you type in input in RCBasic, it runs this. When you do like trying to get the absolute value, it'll do this. And like this push num stuff, I'm about to explain now because since we made a function and not a subroutine, we're going to need to use it. So, well, actually, let's go ahead and add it first, and then I'll explain it later. We're going to go all the way to the bottom of this switch statement. It's a really large switch statement. There we go, all the way at the bottom here. And then we are going to open up RCBasic underscore dev3, and we scroll down and take this, Control C, the case for the test function we just made, and then we just add that down here. And now whenever the case function, whenever our test functions run, it's going to do whatever's in this case. But it's important to note now, since well, actually, we need to add it to one more place, and then I'll come back here. So before I explain the rest of that, we need to go into this file, rc underscore defines, and all of this, we're going to scroll all the way to the bottom, and we're going to just take, actually, we could just copy all of it together like we did before. So Control C, and then we're just going to delete all of this and replace it with the new stuff. And now you see our fn test is on here now too. Which I'll explain all of this much later. But for now, I will explain why we're going to need to use this function push num. And it's because when let me go back to this. Inside of the RCBase underscore build file, you see this file, VM underscore ASM. This is not actual assembly code. This is like a virtual machine assembly code that I made up, basically. So whenever a function returns, like let's say a function is returning a number, it's gonna push the number that function returns onto a stack, and then it like will call return, which will like make it jump to the point in the code where that function was called, and then it'll pop that number off the stack there, which is basically returning that number. So when a function is called, when a number function is called like test, we need to push the return value from test onto the stack. And you have to, because whenever the function returns, it's going to call pop. And if it tries to pop something off the stack that's not on it, it's going to cause like a memory error and it's going to crash. So there has to be a number on that stack if a number function is called. So anywhere you see number function in here, there is a RC push num call to push it onto the stack. Same thing with if it was a function that's returning a string, there's a RC push str for that. So we're going to use RC push num, and then we need to give it a number to push onto the stack. So we'll for test fn test, we'll just tell it like cout hello world, and then we'll have it push the number 42. And so that way, whenever bouncing around a lot, whenever the test function's called, actually we're taking an arg, so we'll output that arg. So instead of cout hello world, we'll cout that arg, which we can get from here. This is the argument here, test underscore arg. So copy, and we will paste this test arg. And so whatever we type in for arg, it will output here, and then the function itself will return 42. So with that, let's go ahead and build. All right, so now we've built a compiler and runtime, which target, and we built them as release. So to see our new binaries, code blocks puts them inside of the bin and inside of the target folder. In our case, it's just release. So this is the compiler, the new compiler we just built. And let's just go ahead and put this in the same folder with the new runtime we built. So I have them both in the same folder. And now I'm just going to create a test program, tst.bs. And so inside of our tst.bas, we will call our test function. So we'll say x equals test, and then hello world. And then print x equals, and x should be equal to 42. So Control S to save that. And now I'm going to open up a terminal and use this compiler in this folder to build it. So ./. I'm on Linux, so I'm using the /. If you're on Windows, you're going to use that, the other slash. But so let's see, RCBasic underscore build and our tst.bas file. And we get this CBC file, which is our actual program compiled. And now we're going to run it with our new runtime. So RCBasic underscore runtime. Oh wait, I forgot to pass the program to it. So tst.cbc. There we go. And it output hello world, which is what I passed as the argument to the function here. And then x equals 42. So our function was successfully added, and it's working now. And if you were only interested in building and being able to add functions and stuff, that's as far as you need to go. But I'm going to also briefly go over what all is in this .cbc file. So inside of the compiler, that CBC file is generated by this function right here. Which it's taking all of this code, at the start of it, the compile process is happening, and some really terribly written code here. So this is where the compile process starts. It's reading each line, and the actual magic is happening here in eval. Eval takes each line. So let's say eval is taking x equals test hello world. Let's say this was the line being passed here. It's taking that line, and first thing it's doing, this is clearing all of the stuff that was used to evaluate the previous line. So it's starting fresh. This is basically ignored unless the line has starts with dash hashtag var, which is a feature of RCBasic I don't even think I ever mentioned in the documentation, but you can do that. Let's just say I put hashtag var here, and then I run this. Uh, it's not working. I might have just disabled it, but what this was supposed to do is, like, when you have hashtag var on the line, it would output every variable and stuff. And then this is ran tokens, which we go into where is it? Tokenizer.h. It is running this function on that line, and it basically turns every character, well, the line into tokens. So well, I don't need to actually go through all of this code, but I can show what it's doing. So let's say with this line, for instance, the X is going to be this token. It'll be ID X. And then the equal sign will be an equal token. And then test will be another ID. So ID test. And then open parentheses will look like that. And then you have a string hello world. And then a closing parentheses. So that is what this line will look like when this tokens function is done running. And then it goes to the preprocessor, which preprocessor is only used for include and I think the array functions because of the weird way that I made them work. Kind of a holdover, but mostly just it was mostly just for include. Not really too much to go into with that. Um, and this is for handling lines that I wanted to split up into multiple lines. So something like if I did like dim x comma y comma z, it this stuff right here takes this and it turns it into three separate lines: dim x, dim y, and dim z. So you could still type this in, but like the compiler has to have something like this in order to for it to work. So that's what all of this stuff inside of this loop is doing, and it's also taking care of that colon, so that if you had something like colon print hello world, this print hello world will just be another line that's added. Oops. Right, and yeah, it's still more of that. And then this check rule is where it takes all those tokens and it figures out how to convert it into the machine code using those instructions here. So it takes all of this stuff and it'll figure out um, how to look at these tokens and break it down into the correct machine code for the runtime to be able to run it. Um, which, most of that work is done inside of this file right here, parser.h, which is huge. It's a it's a really big file. Um, but yeah, a lot of and this function I'm in right now, it's not even. There's just so much inside of this file. I actually am mind blown by how big I let this file get. But like yeah, it's like let's say the first the first the first keyword on the line was function. It'll run this and it'll like make a function based on your declaration and stuff, and has these error messages for if it finds like an error while it's trying to make the function and stuff. Like if the function already exists, then it'll output this. Um, and there's rules for like the for loop. Each keyword is their own token. So like inside of keywords.h, you have all the keywords listed, and each of these keywords is their own token. So like, and would become like an and token, and this would be like an or token, and so on and so forth. Like they all become their own token. Um, and the parser is just looking for those tokens. Like if the token's if, it like will create an if block, and then it starts um, figuring out what code to use inside of an if statement based on uh, what you have on the line. So that's why it's called check rule. It's just checking the rules of the language against your line and making sure that it matches. And then if it does, it'll generate code, um, which I'm not going to go into depth in that. But after it generates all of that code, it will create a, a file like I already have an example one. It'll create a file like this. So let's reload. And you see a lot of these are new stuff for 4.0, so these are not currently in the file. They are if you were looking on the feature user types branch. So if you look on that, you'll see all of these new stuff like dim t field, and all of these are new instructions that are being added specifically for 4.0. Like you see I have 4.0, and then all of these below this is new stuff that's not currently in RCBasic if you're just downloading it off of itch.io at the time I'm making this video. Alright, but uh, before it becomes a CBC file, it becomes a file like this where you have all of this, like the assembly code or whatever. And this assembly code goes to RCVMASM, and inside of, what is it? Yeah, inside of this gen bytecode, it'll look at like the start like at each instruction, and then it will write a number. So like for instance, if you're moving something from a number register into another number register, the instruction will be 32, and then each of these will become a number. So like let me go back to this. In this case, well, this is moving a raw number into it. So like if you look up, scroll up a little bit. If you look at here where I say move a raw number into n, um, if you're moving a raw number into an n register, it's going to be 33. So if we look here, if the first argument is n and the second argument is a digit, starts with a number or a negative sign, then it's going to use 33 as the instruction. And then n will be just like, if let's say it's like n yeah, where is it? In this case, let's say it's n0. So it'll write 33 0, and then the floating point equivalent of 55 into the CBC file. And it does that for each one. And then when you get to the runtime, um, we scroll on down here. When it's reading through like each instruction in runtime, let's say it encounters the number 33. It'll read an integer and it'll read a double from the CBC file, and then it takes those two numbers and passes it to this move 33 instruction, which moves this double number into the N0 register, which we can just go up and look at what's happening when that runs. Let's go to move. Uh, this is some very, very, very poorly organized code. Um, so yeah, here we go. Move 33. We're taking this double value and we're moving it into the N. Well, let's just say this is N1. In this case, is 0. This will move it into VM 0.value, which is the N0 register. VMN is the N registers, and then VM underscore S is the S registers. And then you have VM underscore U, which is the register for user types, which is something I added. So basically, every type in 4.0 is just a user type, and then it has like a type index, which determines how that type is set up, which really complex stuff I'm not going to go over. Um, I think that about covers everything. So that covers like how a general overview of how programs work, what's being stored where, um, and like the runtime and the compiler stuff. I wasn't gonna go over Studio because that's its own separate beast with its own share of headaches and stuff with it. But in the runtime, main.cpp is where most of it is. In fact, you can get rid of its dependency on basically everything but SDL just by getting rid of, not including the RC underscore media or RC underscore matrix or process or geometry, um, and then just deleting every function after the standard library functions. So if you deleted every function from window open on down from here, well, actually, I think timer and wait also use SDL. So everything from here on down and then get rid of those includes. Your only dependency left would be SDL2 itself, and that's just because SDL2 is used here. Um, when this is the function that loads the CBC file into memory, and it uses SDL to do that. The reason I chose to use SDL for loading it rather than Fstream or like C's built-in I/O is that this is cross-platform, as in it will do what you expect it to do on Android as well as Linux and Windows and stuff. On Android with Fstream, it won't work. It's because the CBC file is technically within a zip file, the .apk and stuff. So, yeah, that is everything. I'm sorry that this video went on longer than necessary, but I'll have it split up into chapters so that the stuff that you probably care about will just be a lot easier to find. And that's it until next time. I'll see you.